are going to build 20 of these systems.
This study was undertaken to create an understanding of grey water characteristics and to demonstrate application of low-cost small tower gardens for grey water treatment at household level and reuse in a peri-urban settlement. Kasubi Zone 1 is one of the suburbs in Kampala, Uganda, characterized with diverse people who came from their ancestral villages to start their urban life. Grey water is all household wastewater except that coming from the toilet.
Now, having found that there was too much pollution load in terms of nutrients, in terms of solids, in terms of pathogens, which was also in addition leading to smells and colored water flowing within the environment, we decided to investigate further how we can clean this water.
Due to large population, limited land and lack of drainage, disposal of grey water is a challenge. The common sources of grey water here are kitchen, bathroom and laundry, with the majority of the households, 72%, pouring laundry water in open and spaces adjacent to their homes.
Before they come in, we have been just pouring water anyhow. We have been mixing wastewater and other types of waters in one thing.
Research has shown that grey water is a source of nutrients which contaminates lakes and other surface water bodies around Kampala. These nutrients consume all oxygen, produce toxic algae, killing fish and all other aquatic organisms, a process called eutrophication.
This water is highly polluted. It contains a lot of nutrients, it contains a lot of solid particles, it contains high levels of BOD and also some levels of pathogenic microorganisms.
To address the problem of grey water in this area, Makerere University Department of Civil Environmental Engineering, together with UNESCO, Institute for Water in Netherlands and Sustainable Sanitation and Water Renewal Systems, Ministry of Water and Environment, National Water and Sewage Corporation, and Kampala Capital City Authority constructed treatment filters of grey water in the area.
So we designed a unit that has gravel at the bottom. It has charcoal, which is carbon. It also has crushed lava rock, which has been sieved to particular sieve sizes, as well as mulch. Now, from the studies that we did at the university, we discovered that the combination of this material will help reduce the concentration of the pollutants to a level that is at least adequate to discharge into the environment as approved by the NEMA standards.
Treating grey water in filters can reduce nutrient loading in the downstream lakes, rivers and swamps around Kampala. This can be very beneficial for the survival of these waters and for the economic well-being of people who depend on those waters for their income, for example, fishermen.
About 80% of this is channeled back into the environment as grey water. So if we look at it, on average, each member of the household using 20 liters of water per day, then they discharge out in the environment 16 liters per day, which is equal to 80% of the water that they have consumed. Now this water is highly polluted. It contains a lot of nutrients, it contains a lot of solid particles, it contains high levels of BOD and also some levels of pathogenic microorganisms. So the treatment filter here that we have constructed is able to treat this water and remove a high level of these contaminants to up to more than 90%, and then discharge the water back into the environment without polluting the environment.
The project team, together with the area local leaders, frequently carried out awareness meetings to help the community appreciate the importance of these treatment tanks.
I find that the previous studies we've done on fresh grey water quality from the bathroom, the kitchen and the laundry of the households in Bwaise slum in Kampala we found that there were extremely high concentrations of disease-causing organisms. In the slums, there is a very large quantity of grey water that is discharged to downstream areas.
These filters are designed where urban dwellers pour water coming from washing activities, plus bathrooms. The water is filtered before it flows into the environment. In addition to nutrients that contaminate downstream water resources, the populations living in these settlements are vulnerable to health risks given increasing waste, solid and liquid generation. In slums of Kampala, for example, grey water is indiscriminately disposed of in drainage channels and open spaces, resulting in breeding grounds for malaria, causing mosquitoes and highly polluted and smelly stagnant waters, which are a health hazard particularly when children play in them and contaminate shallow groundwater sources.
When this water is not treated, the immediate effect that you see here is that it will be smelling and it will be colored. So aesthetic issues come in, and also the smell issues. And of course also small children are playing around and they can get high levels of contamination, they can get pathogens, they can get diseases. And in the end also this water, when it goes, it will continue up to Lake Victoria. It will be discharged into the lake with a high level of nutrients, and these nutrients are going to cause excessive growth in the lake. And once that happens, you can have die-off of organisms in the lake, including fish.
In most cities in developing countries, the increasing urbanization has resulted in the development of densely populated peri-settlements, slums. These settlements, inhabited by the poor, have increased the demand for water supply. However, the municipal authorities in most of these cities have limited capacity to provide basic services, adequate safe water, excreta, solid waste and grey water management to these communities, resulting in poor environmental sanitation. With increasing demand for fresh water, there is an urgent need for alternative water resources and optimization of water use efficiency through reuse options. There is also an urgent need for integrated catchment-based interventions that reduce contamination of water resources. Experiences elsewhere in the world indicate that grey water can be a cost-effective alternative source of water. This is primarily related to its availability and low concentration of pollutants compared to the combined household wastewater.